Hello everyone, this project is about LPG gas leakage detector and rectifier for the alert system. I'm Keerthika and I'm going to explain about introduction, problem statement, objectives, functional requirements and scope of the project. So this is the outline of the project. Introduction. Let's see introduction about the LPG. Liquefied petroleum gas is the most commonly cooking fuel used throughout India. Besides being cheap and easily available, LPG serves as an ideal fuel for cooking purposes. With the increase in the number of people using this fuel, it is the need of an hour to provide some safety measures which are required to be implemented to lead an accident-free life. The major accident related to the use of LPG happens due to the leakage of gas, which is dangerous. Gas leaks can occur from the gas cylinders, which are used in almost all of the household of India. So the importance or need of the application of LPG gas leakage detector and rectifier. First is to avoid accidents. Fire accidents due to the gas leakage are avoided. It avoids the exposure of human beings to hazardous gases which affects human health. This can be applied to any setting like home, car, or gas agencies and industry. It is not specific to any particular industry. Second one is to save energy loss. Energy caused a high in leakage can cause significant loss. By gas leakage detection, energy can be saved by the amount of fuel used in the system. This is a problem statement of our project. To develop a model that detects, alerts a concerned user about the leak, and rectifies LPG gas leakage. These are the objectives. First one is to study GSM, that is Global System for Mobile Communications, for efficient communication between sensors and controllers. To study about sensors, that is MQ6 sensor used for this project and their technologies. To develop a low cost model because the proposed model and the existing models are of high cost, so we are using a low cost model for the LPG gas leakage. To develop an efficient system to alert the consumer through mobile by the location of GSM. This is a feasibility analysis, which is meant by flexible by cost and whether it's flexible for the members who are doing the project. This LPG gas detector and rectifier is practical to build technically and use conventionally. This project is feasible with low estimated cost. Use of this system will be profitable in homes, cars, or gas agencies and industries wherever gas leakage can happen because of liquefied petroleum gas. Benefits the consumers of LPG who can use it without any fear of leakage or accidents. Satisfies the requirements to stop the gas leakage, rectify it, and alert the user. This is the scope of project. Why do we use this project? Considering the recent rise in the use of LPG in developing countries due to its cheap price, less soot and low smoke, the need for an efficient system to detect the leakage in the gas and to timely correct it is important. Thus, a project is not limited to just the household where LPG gas is used, but also expanded to factories, industries, vehicles, etc. These are the functional requirements. For this project, we use a gas sensor MQ6 over the capability of detecting and correcting a gas in the air. In case of a leak, the gas supply should be immediately stopped to prevent accident, and this is done with the help of a solenoid valve drive unit. The user is also alerted through an SMS alert with the help of a GSM module. A buzzer is sounded and the LED lights up if the gas leakage starts. Mradima will explain about the non-functional requirements. Thank you.
Hello, this is Sharma, and I will be continuing this presentation of our project on the detection and correction of a leakage in an LPG gas and sending alerts to the concerned user. I will be talking about the next few topics. I will be starting with non-functional requirements. So the model that we are preparing is easy to use and will not require prior knowledge of using the model. It will require very low maintenance and only timely changing of the battery, that is the power supply, will be required. The response time of the model of the gas leak for the gas leak is very fast and hence no delay in detection and correction of the leakage, and thus accidents will be prevented. The device is portable as it uses only a battery power source instead of a plug-in power source. So now we'll be talking about the model. Our main component is an Arduino Uno microcontroller. It will be connected to the power source. We will be connecting it to the MQ6 gas sensor, the solenoid valve, the LED, GSM and buzzer, that is all the other components. So now in case of a gas leak, the MQ6 gas sensor will detect the gas leak and will send a signal to the Arduino microcontroller. After this, the LED is lighted and the buzzer is sounded. Also, the signal is sent to the GSM module with the help of which an SMS alert is sent to the concerned user. Now, after connection and alert, the signal is sent to the solenoid valve, and the solenoid valve helps in turning off the gas supply, and the leakage is stopped. So now we'll be talking about the list of hardware components, starting with gas sensor, power supply, Arduino Uno microcontroller, GSM module, buzzer, LED, bridge rectifier with capacitor filter, and normally closed solenoid valve. So the first hardware component is our gas sensor, which is an MQ6 gas sensor. The vendor is Ajax. The price is rupees 169. The specifications of this will be the working voltage is a DC voltage of 5 volts. The working current will be 150 milliamperes. And this gas sensor module is useful for gas leakage detection in home and industry. It can detect LPG, iButane, methane, alcohol, hydrogen, smoke, and so on. Based on its fast response time, measurements can be taken as soon as possible. Also, the sensitivity can be adjusted with the help of the potentiometer. The next component we'll be talking about is the power supply. So this will be used to supply power to the LPG gas leakage detector and rectifier circuit. So the model that we'll be using is an HLK PMO3. The vendor is Highlink. The price is rupees 250. And the specifications of this are that it is an ultra thin, ultra small power supply source. Although it accepts all voltage inputs and it has high efficiency, high power density. The next component that we'll be using is an Arduino Uno microcontroller. The vendor is Cloudtail India. The price is rupees 451, and the specifications are that this is a microcontroller board which is based on the Atmega 328. It has 14 digital inputs or output pins, of which 6 can be used as PWM outputs, 6 analog inputs, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. So this will be used to connect all the components, that is the buzzer, the LED, the GSM, when the gas leakage is happening. Thank you.
Hello everyone, my name is Shrestha Burman and I am here to talk about our embedded systems project, LPG gas leakage detector and rectifier. My teammates Keerthika and Mradima have already spoken about some of the components of the project, and I am here to talk about some of the hardware and software requirements of the project. The first hardware requirement is GSM module. GSM is used for mobile communication modem. It stands for Global System for Mobile Communication. GSM, the model we are using here is A6 GSM GPRS kit module. The vendor is Greylogics and the price is around rupees 650. The description of the GSM module is that it is used to send an SMS alert to the user whenever a gas leakage is detected. The next hardware requirement is the buzzer. The model used here is 5X buzzer. The vendor is HXD. The price is rupees 99 and specification, it is 3 to 9 volt DC buzzer. Whenever a gas leakage is detected, the buzzer is turned on, so it acts as a gas leakage alarm. The next hardware is LED. The model is T10W5W automotive LED bulb. The vendor is Global Sources. The price is $0.123. It is a 5050 SMD 2 LED 12 volt DC voltage. LED stands for light emitting diode. It is a semiconductor light source. The leakage of the LPG is indicated by using the LED light. The next hardware component is the bridge rectifier with capacitor filter. The model used is GBPC 5010 diode bridge rectifier. Vendor is Magideal. The price is Rs 200. Specification: it is 50 ampere 1000 volt AC to DC. Description: it gives a rectified DC power supply for powering the various electronic basic components from available AC main supply. The next hardware requirement is normally closed solenoid valve. The model is CJV23C12A1. Vendor is SRS Tech Trader. The price is around Rs 499. It is a plastic structure. Voltage is 12 volt. Rated current is less than 110 milliampere. It has a DC resistance of 114 ohms. The solenoid valve system acts like a first aid. Automatically uses a normally closed solenoid valve for the shutting off of the gas valve before calling for help, an audible alarm to those within the environment. The software that is used is Arduino Software IDE. The version is Arduino 1.8.4. The open source Arduino Software IDE makes it easy to write code and upload it to the board. It runs on Windows, Mac OS X and Linux. The environment is written in Java and is based on processing and other open source software. This software can be used with any Arduino board. The references of all the hardware components are given below the slide. These are the references of the project which we have taken. Thank you.
Hi, this is Keerthika. This is a project we are going to explain about LPG gas leakage detector and rectifier with alert system. These are the outlines of this presentation. First, it is system overview. The system can be mostly useful in homes than industries. LPG gas leakage detector and rectifier system manages throughout its life cycle, that you can use it throughout your life cycle, from setting up a structure, from planning a structure, to connect and design the system, and to execute and compile the project. So you can connect according to the rules and you can execute using Arduino. This system can be especially used in simple and efficient way, not costliest way. Prevents fire accidents and saves energy loss which happens due to the gas leakage. Helps customer to know the status, like if the gas leaks you can know it before itself and book the gas in the booking station. These are the design considerations of system architecture. The action taken is to follow a set of rules and procedures for connecting the circuit. There are a set of rules and steps to follow to connect the LPG gas leakage detector with this computer. The circuit acts as a rectifier of the gas leakage, acts as a primary system to protect from leakage injuries by sensing the gas leakage through sensor, implements a shut-off mechanism which acts as a first line of defense in the prevention of coincidence. The system will offer a security alert by means of LED and buzzer. This is the system architecture. Like this 12 volts is connected to this bridge rectifier, or otherwise you can connect your laptop to the LED, and you can connect it to the GSM sensor to stop the to sense a gas leakage. And these are the resistors 1 kilo ohm and 10 kilo ohm, and this is connected to a Arduino microcontroller which we use in software also. And this is a solenoid valve to stop the gas leakage of the in the to reduce the concentration in the air. And this is a buzzer, so it can allow the consumer. These are the detailed system design which we are going to explain this diagram. The voltage power supply is connected to the bridge rectifier. Otherwise, you can connect your device to the circuit. The circuit is connected to gas sensor to sense a leakage. The sensors are attached to the resistors to resist the current flowing through the system. The system connected with the LED and buzzer to alert the consumer of the LPG, and then it is wired to Arduino UNO microcontroller for running the software to sense the leakage. Solenoid valves are connected to stop the gas leakage dissolving in the air. LED and buzzer alerts if the gas level reaches below the threshold limit value. And this is the GUI design, graphical user interface design. Like when you give it to other users, they don't know how to run the software, so they click and know what are the uses and what can we do with that menus. So when we interface Arduino with the hardware, we need to be careful not to exceed the limits. The Arduino consists of LED libraries to provide easy and useful programming of all addressable and non-addressable LEDs. The detection system is developed by using GUI. It is used to display the level of gas concentration in a place through another remote personal computer and via internet server. Hence, it provides benefit to monitor the condition of a room in a safe distance. We are using LabVIEW in this system. It can be used to configure the operations and measurements of the circuit. Also, GUI created using LabVIEW tool is more interactive, facile, and effective compared to the reported methods. And these are the invention details. This will be explained by Shrestha.
My name is Shrestha Burman, and I am here to talk about our embedded systems project, LPG gas leakage detector and rectifier with alarm. My teammate Keerthika has already spoken about some of the topics in this PPT, and I am going to start talking about the invention details. What are the objects of the invention? The objects of the invention are to study GSM for efficient communication between sensors and controllers. So we study about the GSM module as well as sensors and controllers. To study about sensor and its technologies. It is used to develop a low-cost model for the LPG gas leakage detector and rectifier, so it reduces the cost and makes a customer-friendly model. To develop an efficient system to alert the consumer through mobile by the location of the GSM. Brief description of the drawings. Example embodiments of the present invention and their advantages are best understood by referring to the drawings, like numerals being used for like and corresponding parts of the various drawings. The working of the LPG gas leakage detector and rectifier system can be easily understood by referring to figure 1. This figure, it shows the block diagram and hence it shows the working of the system. The Arduino microcontroller is used to control the buzzer, LED, GSM when gas leakage occurs. The components of the invention are shown, which are power supply, Arduino, LED, buzzer, MT6 gas sensor and solenoid valve. So this is the block diagram figure 1, in which we see the power supply, the solenoid valve and MT6 are connected to the Arduino. The Arduino UNO multi-controller is also connected to the LED, GSM and the buzzer. Figure 2 shows the flowchart cum schematic diagram of the LPG gas detector and rectifier circuit. So the flowchart shows the flow of information, how it goes from one state to another. In the beginning, the interface with the Arduino microcontroller is established. Then all the input and output connections are set. After that, the power is supplied to MT6 gas sensor. So in the beginning the interface is established, then the input is given and the output connections are obtained, then the power is supplied to the MT6 gas sensor. The input is given to the MT6 gas sensor module, the output is checked. If the output is low, then the LED and buzzer are turned on and SMS alert is sent to the consumer. If the output is high, then the LED and buzzer is not turned on. This is the flowchart, that is figure 2. In the beginning, the interface with Arduino microcontroller is established. After that, the input and output connections are set. After that, we supply power to the MP6 gas module, get input from the MP6 gas sensor module. If the output of the sensor is low, then we turn on LED and buzzer and send message through GSM. If it is not low, then we turn off LED and buzzer, then the circuit stops. Thank you.
Hello, this is Mradima Sharma, and I will be continuing the presentation as mentioned. I will be covering the next two topics. The first topic that we will be covering is the invention details. For the next figure, that is the figure 3, shows the use case diagram of LPG gas leakage detector and rectifier system. The actors are the user, the LPG gas system, and the consumer. The use cases for the actor are connect input and output, and connect power to MP6 gas sensor. And the use cases for LPG gas system are it alerts the consumer to message, and the buzzer and the LED sets on if the gas output is low. The use cases for the consumer are reports the booking station as message arrives, and if serious reports, fire visit. The next figure will show the architecture of the LPG gas leakage detector and rectifier. So here the power supply unit supplies that is the main voltage of 220 volts is converted, is stepped down by the transformer and to approximately 12 volts AC voltage, and then it is converted to a pulsating DC of 12 volts with the help of a bridge rectifier and capacitor. This power is supplied to the LED, the GSM, the microcontroller, the MP6 gas sensor, the buzzer, and that is all the components of the system. So now, in case of a gas leak, the MP6 gas sensor detects the smoke or the gas, and it sends a signal to the Arduino microcontroller. The Arduino microcontroller further sends a signal to the LED, which lights up, the GSM module, which will send an alert to the user, and the buzzer, which makes the sound. The next topic that we'll be covering is the working examples. The first working example is that consider that the gas leak and the sensor recognizes the leakage. It gives the alert by buzzer and LED. After the buzzer sounds and the LED lights up, the GSM module alerts the customer by message. The second working example is when the gas leakage gets detected, the customer informs the booking station, and if something serious happens, it informs the fire brigade immediately to prevent fire accidents and save energy by preventing the loss. Our next topic is the pseudocode. So the pseudocode that our implementation, that is the pseudocode, we will be using a red LED, a buzzer, and the MP6 detector. So we've connected our Arduino microcontroller along to the breadboard and all the components on it. So the red LED will be connected to the 12th pin. The buzzer is connected to the 10th pin. The smoke A05 is given the value of A5, which is the fifth pin in the Arduino microcontroller. We have set the threshold value to 400. It can be adjusted depending on the required need of the user. There are two functions that are required: void setup and void loop. So in the first setup, we will use a function called pin mode. So the red LED, that is the LED, is set up as the output. The buzzer is set up as the output, and the smoke A0 is set up as the input. Then we will the next function that we use is the void loop. In this, the analog sensor reads if there is a smoke. If there is a smoke signal detected, then we confirm with the threshold value. That is what we've given. So we gave the threshold value as 400, and if the threshold value is matched or is increased, increased, then the red light will be turned on and the buzzer will be buzzed. Thank you.
This is a project we are going to talk about. I'm Keerthika, And these are the outlines of this presentation, and this is the importance or need of the application of LPG gas leakage detector and rectifier. First is to avoid fire accidents due to the gas leakage. It avoids the exposure of human beings to hazardous gases which can affect their health. This can be applied to any setting like home, car, or gas agencies and industries. It's not specific to any particular industry. Second is to prevent energy loss. Energy costs are high and leakage can cause significant loss. By gas leakage detection, energy can be saved by the amount of fuel used in the system. This is the problem statement of the circuit. To develop a model that detects alerts a concerned user about the leak and rectifies LPG gas leakage. And these are the objectives of the system: to study effective communication between sensors and controllers, to study about sensors and their technologies, to develop a low cost model for the LPG gas leakage, to develop an efficient system to alert the consumer through mobile. And this is a model. This is a power, or we can connect PC computer. And this is Arduino Uno microcontroller, solenoid valve to stop the gas leakage, MQ6 gas sensor to sense the leakage, LED to blink, and to buzzer to alert the consumer. The design of LPG leakage system is proposed for home safety. This system detects the leakage of LPG and alerts the consumer about the leak. And the emergency measures the system will turn off the power supply while activating the alarm. The additional advantage of system is that it continuously monitors the level of the LPG. And the circuit for LPG leakage device is readily available in market, but it is extremely expensive and variably based on microcontroller. The objective is to sense gas leakage anywhere. LPG gas is applied in pressurized steel cylinders. The gas is heavier than air when it leaks from a cylinder. Then a long floor and tends to settle in the spots such as basement. This can cause for suffocation of air if not dealt with. So we introduce an alarm so that it detects the leakage of gas and alerts a user through audio visual indicators. This is a LPG gas system applications. We can use in homes for cooking or boiling. We can use in laboratories or medical colleges to study about, and we can use it to burn chemicals and find solutions. Restaurants, industrial kitchens to cook, boilers and cars so that we can need for emergencies. And implementation demo video will be explained by Mradima.